Chapter 11, Review Page 1. I'm not going to show all my work perfectly here. I'm going to talk through these problems, but some of these are straightforward from the formulas here. The sum of the interior angles is equal to n minus 2 times 180. So we want to do 33 minus 2 times 180 degrees. So that's going to be 31 times 180 degrees. We will get 5,580 degrees when we do that calculation. Measure of each interior angle in a regular dodecagon. Yes, you do need to know these. That is a side of 12. Since it's regular, I don't actually like using the interior angle formula. I realize that every interior angle is supplementary to the exterior angle. And to find one exterior angle, all you have to do is 360 divided by n, in this case 12. So basically what I've done here is I have found that an exterior angle is 30 degrees. So if the exterior angle is 30 degrees, what does the interior angle have to be? Well, they are supplementary. So the interior angle has to be 150. And that's my favorite way of doing those problems. All right, find the number of the sides of a convex polygon if the interior angles have a sum of 21,240. So following our formula, now we actually know the sum. We know the left side. 21,240 is equal to n minus 2 times 180. Okay, two ways to go about this problem. You could distribute, or you could simply just divide by 180 to both sides right off the bat. So if I do that, I'm going to get 118 equal to n minus 2. Adding 2 to both sides then. Slow down when you do this. I see so many kids give me an answer of like 116 here. The answer is 120. Just slow down and make sure you're doing your small things correctly. Number 4, number of sides of a regular polygon if the interior angle is 140. Again, guys, you can use the interior angle formula, absolutely, and you can work through that. But I know that, therefore is what those dots means. Therefore, to me, the exterior angle has to be equal to 40. So using my formula of exterior angle equals 360 over n, I'm now plugging in over here. So the exterior angle is 40 equals 360 over n. These guys do the old switcheroo when you solve. So n is equal to 360 divided by 40, where we get ourselves 9 sides. A regular nonagon is what that would be. Each exterior angle in a regular pentagon, see, now's the time where it's actually intending for you to use this formula. So again, exterior angle equals 360 over n. In a pentagon, there's 5. So that comes out to 72 degrees there. Just remember, just be very careful as you do these problems. You realize the reason we could do those formulas on these last 3 here, sorry, not that one, but up here as well, is that the word regular is in there. Okay, there's some formulas that only work for regular polygons, and hopefully if you understand the formulas, you know why. All right, number 6, a little complicated here. Find the area of a regular nonagon with sides of 10. All right, well, the nonagon, I like to show it as this is the part of the nonagon that you need to really focus in on, this right triangle. When we do 360 divided by 9, because a nonagon has 9 sides, we actually get the value of 40. So 40 degrees is each triangle, but then when we divide by 2, that angle right in there becomes 20 degrees. All right, so hopefully you're hearing this as I'm talking through and not showing all of my work in this small space. Got to find that angle. Once you know it's not a hexagon in here, you know it's going to use trigonometry. All right, so the area of this one, that most of you are probably doing the formula, is 1/2 Apothem times perimeter. Now I say that because you could actually find the area of this triangle right here and multiply by 9, because there's 9 of those triangles. But we've been using this formula a lot in class. So this is 1/2 the Apothem. Well, how am I going to find this Apothem? Side of 10 was given to me. So that makes this a 5, this a 5, and the side of 10, so we'll wait for our Apothem, the side of 10 actually makes the perimeter 90 since we have 9 sides. So really the whole goal of this problem is to find the Apothem. Well, I have the 20 here, so I'm going to use tangent here. So let me change colors. So off to the side, I'm going to say the tangent of 20 is equal to 5 over a. And then switch those, and we're going to get a equals 5 divided by the tangent of 20, and that value actually goes right in here when you're going to actually calculate the area. All right, so once we do that and we complete that calculation, that comes out to approximately 618.182 centimeters squared. Again, if you're struggling, wait, I didn't get that, but I have this, you need to be careful putting it in your calculator. And that's something you need to work on. Find the area of an equilateral triangle with a radius of 12. All right, so here's the deal. Once again, we've done a lot of these now, but I hope we're getting the hang of it. The radius right here is 12. Just be careful with how you're setting up this 30, 60, 90. This is the 30, and here is the 60. So if that's 12, that means the x value, or the side opposite the 30, is 6. This is 6 root 3, which means the entire length of this side is 12 times the square root of 3. So if I'm doing this, I'm absolutely going to use the formula that is made for the equilateral triangle, and that is s squared root 3 over 4. And when we calculate this, again, the radical squared is really 12 root 3 times 12 root 3. Well, the 12 times 12 gets you the 144. The root 3 times root 3 gives you that 3. We still have the root 3 over 4. And when you simplify, whether you multiply here and then divide, however you do it, it doesn't matter. You get, at the end of this problem, 108 root 3 meters squared for the answer to that problem. Okay, last one on the first page here. The base of a gazebo is a regular 20gon. So again, I'm only looking, even though it's definitely not to scale, I'm only looking at the part that I need for this calculation. 360 divided by 20, that's going to give me 18. Then I need to take that value and divide that value by 2, and I get 9 degrees. And that's the value that goes in the triangle there, okay? So the 9 degrees is in here. What do they tell us? 6 foot sides. So I got a 3 here because the whole side is 6. And again, to find this apothem, just like the last one, a little bit of trigonometry. So we're really getting you to practice these types of problems given a side. 1/2 apothem, well, don't know it, but the perimeter is going to be 6 foot sides times 20, so 120 feet for the perimeter. All right, so again, let me grab red this time, maybe. There we go. We're going to do the tangent of 9 degrees, because of that 9 degrees that's right here, is equal to 3 over a. And then when these switch places, your apothem is actually equal to 3 divided by tangent of 9 degrees. Okay? And then when we do this problem on our calculator, work this out, we get approximately 1,136.475 feet squared. Okay? So I didn't want to do the perimeter of this problem and just walk around this problem. Instead, I attacked the center of it and did the area. Thank you.